Hey guys, welcome back to another RASK maths video, and in this video I'm going to be solving this question here in an interview style. So this question's asking, in a football competition where every round played is a knockout match, how many matches will be played in a competition? So I'm assuming it's asking us how many rounds we need to play to determine an absolute winner. Okay. So maybe we have something like this, where we have team 1, team 2, team 3, team 4. We have something like this, and then these two play each other, these two play each other, these two play each other, these two play each other. Get the winner from each of those and then play them against each other. And then you play these two against each other to ultimately get the last winner. So here we can count the number of matches by just circling them. You have 1, 2, 3, 4, 5, 6, and then we'd have 7. So that gave us 7, which was 8 minus 1 matches. And perhaps we can generalize this to say we play to determine an absolute winner. So this is one team which we know is definitely better than every other team. And we're assuming if team A beats team B and C beats A, then we're assuming C would beat B if they played a match. This is kind of like inequalities. If we're saying A is greater than B and C is greater than A, then we can assume C is greater than B without these two ever playing each other. And sometimes in real life this doesn't actually happen because teams might have different play styles. So if B lost to A, might have a weird play style which A is just able to capitalize on, but then if they played C, they might beat them. But we're just assuming in this case that it's a nice relationship like this. So now, to determine an absolute winner, then we should probably, we need to play every team against, not every other team, but, it's going to be something like this, right? Where we have to play the right number of games so that we can determine conclusively that each team is better. So maybe we can have something like this. Let's say we have n as 5. So this isn't a nice even power of 2 like it was last time. So now we might have team 1, team 2, and we'll try and split this into 2 sides. Like so. Now we need to determine the best from the left side and the best from the right side. So we'll play 4 and 5 against each other, play 1 and 2 against each other, and then the winner of that will play 3. And that will tell us the best from the left and right side. And then we just play these two against each other. So again, we can see we have 1, 2, 3, 4. So 4 or 5 matches to determine the winner. Okay, so it appears that to determine a winner, we need to play n minus 1 matches. You know, that makes sense. And let's see if we can sort of prove this. So if we have n teams, we need to play n minus 1 matches. Let's just say we have each team represented by a number up to n. And okay, so I'm thinking about this sort of like a sorting algorithm. So let's just imagine Okay, so we need to determine the best between 1 and 2, and then we'll get some kind of winner. Let's just say this was 1. Now we determine the best between 1 and 3. That gives us some kind of winner. We can determine 3. So now we know what the highest is in the first 3 teams, and you can see we've already played 2 matches. Now, out of the first 3 and a new incoming team 4, we need to determine the best out of those, and let's just say it's still 3. And yeah, we just continue this on, and we'll, every time, essentially, we get a number, and we're just trying to see which one is new. Sorry. Okay, so this is kind of like a sorting or min or maximum algorithm if these are all in an array and we were just going through each one. So once we're at position, I don't know, I in the array, we know what the greatest team up to that position is. And so we've had to do n-1 comparisons to get up to there. So it makes sense that to get the absolute winner, we need to play n-1 matches. Okay, so there's my answer for the winner. But now we need to, the question doesn't just ask to determine a winner. It says how many matches will need to be played in total. So perhaps it wants to know how we can determine the overall standings. So we have number 1, number 2, number 3, all the way up to number n. So how many matches will we need to play to determine these standings? Because right now, if we play these n-1 matches, we will know who the ultimate best is. And if we look at it in this table format, we'll know, so this person over here was the best from the left side. This person here was the best from the right side. So when we play them against each other, we'll know that who's the best overall. But who would be the second best? Would it just be the loser of this side? If it was the loser, well, we don't know whether there was someone on this side who might have, for example, 5 might have beaten 4 here. So 5 might be a winner here. But 4 might still be better than this guy. We just don't know that. And what we're assuming is that if 4 was better than this guy, it shouldn't matter because 5 would end up beating this guy, since 4 is greater than this and 5 was greater than that, which means 5 would win overall. But that means we can't just conclude that the person who lost in the finals is the second best. That's not really how it works. So what should we do instead? Well, let's think about this again. So we have 1, 2, I'm going to go up to, let's just do n is equal to 4 this time. So 1 and 2 play each other, 3 and 4 play each other, and then the winners of that will become the winner. So let's just say 4 makes it here, 1 makes it here, so we have to take 1 in that, and 4 goes here, and then let's say 1 wins overall. Oh, that was pretty bad. Okay, just going to do that. Okay, so now, second best, it could be 4, or it could be 2. What we know is that 4 is the best on the right side, so now we need to compare 4 against the best on the left side. And we know the best on the left side is going to be the person who lost in the semifinals. Okay, so therefore we have the n-1 matches to determine number 1. Then to determine number 2, we just need to play an extra match where we put the runner-up of the right side against the runner-up of the left side. So let's just +1 to find out number 2. To work out number 3, what do we need to do? Well, okay, we've worked out, let's say, so 1 wins overall, so we know that. Now 4, we'd play against 2 to work out who the runner-up is at number 2. And I'd say, let's say 2 wins this one. So 2 becomes runner-up. Now, okay, so now both of those are from the same side. And we already know 4 is better than number 3 because they've played each other. They come from the same side. So if this happens, then we can immediately just put the rest of the rankings in as 4 and 3 there. But what if instead 4 played 2 and then 4 actually won? So now that means number 2 is 4, and now we need to play 2 against, well, we know it's less than 4, but is it greater than or equal to 3? 4 beat 3, so 4 is greater than 3. Okay, these are actually team names, so it's a bit confusing, but 4 is greater than 3, but is team 2 going to be better than 3 or not? Team 2 is worse than 4. Is it worse than 3 as well? Well, we'd have to play against them. So, assuming in the worst case, we then have to play another match to determine number 3, and then number 4 would just fall out. So we don't actually have to play an extra match because by process of elimination. Okay, so what does this ultimately tell us? Well, in this case, we had to play n+1 matches in total. And let's look at a slightly bigger example. Let's take 4 teams and look at the worst case. So these 2 play each other. These 2 play each other. And then these 2 play each other. So now we've determined an ultimate winner. Let's just say it was 6. And okay, it's easy to think about these in terms of... it's easy to put these as scenarios. So let's just put in 2 wins there, 3 wins there, but then 3 wins there, but then 6 wins overall. Oh no, we'll say 3 wins overall. So now 3's out of the competition. Now we need to play 6 against the second best here. So 6 would have to play against 2. And let's say 6 wins that. So now 2 needs to play against whoever is the remaining best on the right side, and that might be 7. Let's say 2 wins that. Now 7 plays against, well, so let's probably keep track. So we have n-1 matches there to determine number 1, then to determine number 2, we played another one, then to determine number 3, we played another one. Now 7 would have to play, 7 would either have to play 2 or, no, either have to play 1 or 4. We don't know which one it's better than. Okay, that's weird. Okay, we could play against both of them, but that seems a bit unnecessary. I guess we'll have to if we want to determine who the best is. So we'll have to play 7 against both 1 and 4. Hang on. We know 3 is better than 4, and we know 2 is better than 1. And 3 was better than 2, which means 3 must be better than 1. Okay, but that doesn't really help. So I guess if we want to determine number 4 now, we have to play 2 matches. Or no. Or we still have to play 2 matches, but we can put these 2 against each other. And then that should tell you who the remaining best on the left side is, and then we play that person against 7. So then we would get +1, +1, let's determine number 4 and number well, wouldn't let us determine number 5. If 7 wins, then it's at number 4. If 1 wins, then it's at number 4. If 4 wins, it's at number 4. Then a loser. Well, let's just say 1 wins this. Then 7 would go against 4, so you'd have to end up playing another 1 anyway. Okay, so that's +1 again. And yeah, then I guess the only ones remaining would be these two. Number 6, number 7, number 8, and okay. So it looks like we just have to, it kind of follows this pattern here, where we need to play n-1 to determine the winner, and then we just play additional ones until we get to the final team, where we just use process of elimination. So my guess for the total number of games is going to be n-1 plus 1 multiplied by, this would be n-1. Because there's 1, 2, 3, 4, 5, 6. No, n-2 actually. Yeah. And okay, so that's just sum these. That ends up giving us 2n-3, which seems a bit weird. I'm not entirely confident in this answer. But let's check the answers, check the solutions, and see if we are even close. Okay. Number 6. There must be n-1 matches played. Okay, yeah, so it turns out the question just asked for this original part, which we were actually pretty confident on. The n-1 part, that is actually correct. So we got this bit right. It doesn't go on to say how we could determine the rankings. So maybe someone in the comments could leave some kind of suggestion on how we could end up doing this efficiently in the worst case. I'm just going to write worst case here. But yeah, thanks for watching, and that was TBO problem number 6. See you guys in a future video. Bye.